Okay, so I thought I would share with you guys a little bit of insight into some research that I'm doing right now regarding random number generators and trying to track non-locality from them. Basically, starting off, there's this 2021 paper here called Macroscopically Non-Local Correlations, which did show that under certain circumstances, they would literally show that for let me find the control feature here, just give me a second. Gaussian. And what they did show was that not only does they give rise to a non-Gaussian limit, but non-IED states, these are some of the states that can show up in entanglement, that basically there's a non-limiting the non-Gaussian behavior, which demonstrates non-classical or quantum non-locality behavior. So we are looking for in random distributions non-normal or non-Gaussian behavior. Well, luckily for us, we can actually do that courtesy of a radioactive decay random number generator that is referenced by Google Scholar. How it works is that they take two sets of intervals between two sets of radioactive decay, and if T1 is longer, they release a 0 bit, and if T2 is longer, they release a 1 bit. And not only that, all of these bits are pre-recorded, which means that there is a possibility that if you were going to influence these bits, it would have to be backwards in time. Well, interestingly enough, there was a paper from 2013, Entangling photons, which entanglement between photons that have never coexisted, where they successfully were able to entangle two photons that had been decayed at one point and redecayed at another, so, showing entanglement in time. So, that means that we can now use the Z-scores generated by these radioactive decay bits that are pre-recorded to check for non-locality backwards in time. And how do we do that? Well, as it so happens, the International Encyclopedia of Statistics talks about how you can have a sum of the squares of Z-scores, which equals a chi-square score. And there is a one-tail good test univariate goodness of fit test, which is basically to show for normality. So, I took 50,000 Z-scores over the course of over a decade since 2007, and they showed a cumulative sum of squares of Z-score of 50,818.2506. And that was 50,000 runs total. So, pulling up the chi-square calculator, just do that quickly. Chi-square. And here we go. So now we have 49,999 degrees of freedom because it's always n minus 1. Then 50818.2506. Just confirm we got that correctly from the file. Yep. And now we calculate that. And a one right tail univariate goodness of fit test reveals that the odds of this happening by chance, the p-value is 0.004 or 005, so odds of 1 in 200 of this happening by chance. So, apparently we have been able to demonstrate, using this radioactive decay-based random number generator, that there are a non-normal distribution in the Z-scores, and possibly something going on. Whether this is quantum non-locality or not will require checking of the control runs and all the other experimental runs, but at least this is something indicative to go for. We'll see how things turn out.